So good afternoon, ladies and gentlemen. I saw the lady here, but okay. So my name is Miloš Žáček. I'm from Protronix Limited Company, and we are basically we are designers and producers of industrial electronics. And I named my presentation like more perceptions, smarter control, because it's very important to first. Let's say we are at the bottom of the IoT. Let's say. We deal with the sensation, on sensing what we need, and if you sense what is necessary, and then it's possible to make more meaningful, let's say, decision and better control. So that's the reason why I named my presentation More Perception, Smarter Control. So this is our company where we have design centrum and our production centrum. We are located in Chrudim, near to the, let's say, near to the park. It's about 120 kilometers to the east from using the highway D11. And we started the business in 1996, and as a Protronix Limited company, we are on the market from 2001. And one part of our, let's say, research and development department deals with some custom application and custom-made design, and second part is design of our own products. And I would like to pay attention today to our own products, and part of them are sensors. We started with air quality sensors. So when I was listening today the presentation, so I decided to pay a little bit more attention to the problematics of the indoor air quality, because I see there's a little bit misunderstanding regarding the CO2, and so I will brief you a little bit about this problematics. So basically it's our attitude to the customers that we start from some technical specification, and then through design of the product, through some testings and certifications, and in the end, of course, everybody is expecting some successful product. Is our attitude regarding the design. This is just some pictures of design, and this is our EMC laboratory for electromagnetic testing. We are able to test our products or custom-made products in our laboratory. And as I have already mentioned, I would like to pay more attention to indoor air quality problems. We're producing the different type of sensors. It's it's CO2 sensor, water organic compound sensors. I will explain a little bit in more details. Then we add to our portfolio the ambient light sensors and differential pressure sensors. So why indoor air quality sensing at all? So because on average, usually we inhale per day about 15 kilograms of air. I mean, I think it's a lot. And almost 80% of time we spend on average indoor. When I was thinking about this, I realized during the summertime and during the winter time, that I spent, let's say, almost 100% of time indoor. Let's say in the morning I take my car and going to my office. Then I'm in my office till the afternoon, till the evening. Then I take my car and going home and spend almost. I realized, oh my God, it's horrible to spend almost 100% of time indoor. So the quality of indoor air is very, very important, I guess. And maybe you have heard about SBS. It means sick building syndrome, that some name for problem with the health of the people staying a longer time in the buildings. So what are the typical indoor contaminants? This is the VOCs, so called VOCs, volatile organic compounds, that are compounds, organic gaseous compounds, which are in the air, and they're different type of sources. then it's sometimes humidity too high, too low, or carbon dioxide or carbon monoxide. This is the table with typical sources of contamination in the buildings. So usually it's a human base, human body breathing, or animals somewhere. And this is a table where it shows what the main generation of this source, this VOC. It's there up to 10,000 different types of VOC, organic compounds. Then it's some combustion, cooking, and some industrial technology, etc. Of course, smoking. Then it's some painting, some carpets, some furniture. Everything emits some chemicals from this type of things. And maybe you know if you have some brand new house or brand new office and this strange smell, and this is the VOC, which is a basic thing for which we have to use the ventilation and exchange the air. Usually, is measured the contamination of indoor air is usually measured in so-called ppm. It's parts per million. It's acronym from English, parts per million. It's similar to the percent, like percento from Italy. It's, let's say, this is some graph where you can see one red molecule and 999 molecules of air, and so 1 ppm, let's say, of a red molecule in 1 million of molecule of air. And why we use the CO2 as to judge the internal air quality? Because as soon as the CO2 goes up, at the same time it's going up some other organic compounds, like those volatile organic compounds. Basically, we ventilate, or the reason why ventilate the indoor room is because the volatile organic compounds goes up and up, the concentration is going up and up. So, but we use the CO2 as some yardstick for judging the actual internal air quality, or internal air quality, indoor air quality. Basically, the CO2 only is not so harmful, but in the case it's in the connection with this VOC, so then it's very good yardstick to control the ventilation system. So the basic purpose to monitor CO2 is to start to control ventilation in best way and to in efficient way to save the energy for conditioning of the air, for heating the air, and to save, of course, the money at the same time to increase the comfort of the people who are staying indoor. As already know, there's a common trend to increase the thermal isolation of the buildings, increase or build in the new, better windows which are more tight, and the whole house becomes some very close thing, and like, let's say, like some submarine, and without ventilation is a big problem to live there or stay there to be healthy. So if there are a few people inside, the CO2 in time is going little slowly up and up. In the case there are more people, the change of rate of CO2 concentration is much faster, so then it's necessary to start ventilation and control the ventilation system according to the actual concentration of CO2, or better, VOC. Regarding the common levels of CO2 concentration outside is roughly, or on average, about 400 ppm. Sorry to say, but every year is going a little bit up, and some recommended value is about 1000 ppm inside. below this is a, let's say, wasting of energy, wasting of money for ventilation or cooling or conditioning or heating the air. And if the concentration is going up and up, there will be a problem with the feelings and comfort of the people indoor. The maximum is about some usable or reasonable maximum is about 5,000 ppm is maximum limit. With that limit, there's a little bit starting to be a little bit danger regarding the health of the human body. Now I would like to tell you briefly some manifestation of poor indoor air quality. Maybe everybody of us has some bad experience with poor quality. I noticed, or my colleague, my friend from TECO noticed that there was some, I guess in the morning about 10 a.m. there was some little bit strange air or not so good air, and I didn't see any sensor here in this building. So the ventilation system is running, I don't know, according to some timer or according to some manual control, I don't know. So the quality of the air in this room is going up and down and down, up and down, and maybe somebody of you felt it too. So what are the manifestations? Maybe you know it's some lower ability of concentration on something, on your work or paperwork especially. Maybe low efficiency of some meetings. One day I was in some meeting at our customer who was the big producer of a ventilation system, and we were in some meeting room. This meeting room was inside the building and no windows there. But ventilation system was there, but not working properly. We measured the CO2 concentration after 2 hours to stay here, about 8 people. There was concentration above 7,000 ppm. So it's very horrible, really horrible feeling, and nobody has a willing to stay longer in this room, and so it's really very poor concentration, very high concentration of CO2, and of course the other contaminants. So maybe you know it from the school system. I think according to some statistics, in Czech Republic, the school system has a very big problems regarding the efficiency of the school system, and maybe one part of this is the very low quality of air in the classrooms. I have even read some statistic that when you finish the basic school, then the IQ of a children or child is a little bit lower. If somebody finished the high school, the IQ is a little bit lower. If somebody finished the university, the IQ is a little bit lower even too, So there's something wrong. In general, it's not for everybody, of course, but this is a general trend is in this way. So maybe one part of this is a low quality of air. So sleepiness, you feel tired, you feel not interested in anything, just one willingness, it might be to fall asleep or to go to apathy or something, or to run away from some space or room. Maybe somebody of you has some experience when you wake up in the morning and you have some headache or feel tired, or like running all the night, or something crazy. So maybe one thing should be the poor quality of air in your bedroom. And now this is our sensor. You can see here in live or lively over there in the presentation of the company Intelliments, and it's not. I think it's a pity today that we don't measure actual CO2 concentration here, because I think it should be interesting. Next time we will do it for sure. So in this box is built in the CO2 sensor, what I call compound sensor or relative humidity sensor, and we use IQRF wireless communication module. So we, let's say, enter the world of the IoT through IQRF modules, and we add up to our communication protocol. To our hardware communication interface, the RS485 with Modbus communication protocol. And there's a typical using of our sensors is in, let's say, living room, and VOC sensor is for in the kitchen or dining room. Relative humidity sensor, let's say, some bathrooms. And now this was mentioned here with my predecessors, that some integration of our sensors to some through some gateway to cloud and visualization of the data from sensors. So we are, let's say, at the bottom of IoT, like the first line, to sense, to perceive the data, and then they're possible to manage the data, to transfer the data, and then manage them, visualize them, etc. This is the hardware inside of our sensor, and we have added to our communication protocol some new feature that we have two relays inside built in the sensor, and you can remotely control this relays to turn them on or off independently of the actual value measured by the sensor. So let's say it's some expansion board, some small with two relays, so you can read some actual value of, let's say, CO2 at the same time to control something from your application using our two relays. You saw here the integration of, I'm sorry, some older one, but it's without any problem. It's possible to exchange it with the red one, with the new one, IQRF module. I guess the 72 is okay. It's correct. So, yeah. So this is some picture of how it's working. The relays, there are two contacts, one relay, second relay, and it's possible to remotely to preset it, to set the trigger level or control the relay outputs totally independently of sensor of actual quantity or volume of the sensor it's measured. This is some graphs of, we cooperate with CIS company, sorry, CIS company who made for us, which made for us some visualization of our data. So just some example of it. And now I very briefly introduce you to our new sensors, which are suited for some industrial purposes. The first one is differential pressure sensor. Is built in this plastic box, and which has a very high IP ingress protection, IP65, so you can place it almost anywhere. And there's different ranges of the differential pressure, operation temperature from -20 to +60 degrees Celsius. And this is suitable for some application in industry. The first one, let's say, is monitoring the airflow in some ventilation ducts. Then the second thing is to let's say to measure differential pressure directly on the fan, and then it's possible to calculate the actual flow generated by the ventilation, by the fan. Or you can use it, or it's possible to use it to monitor the filters in the ventilation system to check if there's some clogging point of filter, and then to indicate to some serviceman or to send some message or something that there's necessary some exchange of the filter or filters in the ventilation system. Another possibility or other using is in some so-called clean rooms, where you need to keep the overpressure inside to prevent the air from the outside going in the clean room. We have some application where I use in pharmacy. They were packaging some pills, and they have to prevent the outdoor air or air from the corridor. So in the building to inside, so they're necessary to measure the overpressure in this clean room and to keep by ventilation system, to control ventilation system properly, to keep some overpressure in this clean room. Another industrial sensor is ambient light sensor, which is again in the same box, and it has IP65 protection, ingress protection, so it's possible to use it outside, and it measures the ambient light illuminance in lux from 0 to 80,000 lux, and its sensitivity is very close or similar to the human eye. And of course, we use the IQRF communication module in those sensors, so it's very easy to implement as soon as it's handle the communication with one of our sensors. It's no problem to start to use some other sensor without any problem, just to read some different value from the sensor, that's all. This is the typical human eye light sensitivity, and this is in the red is a human light sensitivity, human eye sensitivity, and the black one is a sensing graph of our sensor. So you can see that it's very close to the human eye. And it's possible to use this sensor for monitoring the daylight and then control the, for example, street lights, or it's possible to sensing the light in some industry halls and workshops, etc., then to control the actual power of lighting and the safe energy for lighting. So I reached to the end of my presentation. So I would like to thank you for your attention. And if you have any question, you can ask me now or maybe later, or we can discuss anything. So thank you very much again.